Hello everyone, welcome to the third part of this tutorial series on Lemur. In the last video we talked a lot about variables. We talked about the differences between scalars and vectors, and because you're going to be working with objects and their variables so much while building an interface, it's important that you not have to struggle with that every time you go to use a variable. Now there are obviously a lot of different types of objects you have to work with, and a lot of them use variables similarly, but some of them are a bit more complicated. They're not too bad if you watched the previous video, but I wanted to cover all the variables of all the objects you'll use most frequently, so that this part can just become second nature. Now there are a few objects that we won't cover, because they're more advanced objects, and ones that you're less likely to use right away. Those are the canvas, step note, step slider, and step switch. Those also happen to be newer objects. In other words, they didn't even exist when the Lemur manual was first written. Let's take a look at the manual and see the page we're going to be using today. If you turn to the appendix section of the manual and go to the page Object Variables, you'll see a list of a bunch of different types of objects. Next to each object, you'll see the variables that object contains, as well as a brief description of the variable. Next to some objects, you'll see the word None. These objects do not have any variables, and so we won't be covering them today. Also note that there have been some additions since this manual was created, so some objects actually have a Z variable, even though it's not listed on this page. Alright, with the introduction out of the way, let's get started. The first object we're going to cover is the custom button. Here on this interface, I've created two custom buttons. If I click on one of them and look over in the project, I can see that it has a single variable named x. For custom buttons, x always has the value of either 0 or 1. However, there are two switching modes available in the Behavior tab of the object's properties: switch or pad. On the left side, I've created one that's in switch mode, and on the right side, I've created one that's in pad mode. If I hold down E on the keyboard and click and let go of the mouse, you can see that the button stays on. CustomButton.x is now 1. On the other hand, in pad mode, if I press down, CustomButton.x becomes 1, but then when I let up, it goes back to 0. As you can see, with custom buttons there are no vectors involved, only scalars. So I've written up at the top that the available variables for a custom button object are simply x, and it's a scalar. Each page of this video will cover a similar format in the header to make it easy to understand. Now let's move on to our next type of object, the ring area. I'm going to hold E and switch over to the ring area tab here. Rather than saying holding E on my keyboard all the time, please just know that whenever you see me interact with the control on the screen, I'm holding E on the keyboard. So the ring area object has 3 variables, and they're all scalars. That's because there's only one circle in this object. You can't have multiple circles in a ring area object, so there's no need for a vector. By clicking on our ring area object and looking at the project panel, we can see x, y, and z variables. On the left-hand side, we have these scalar variables listed: RingArea.x, RingArea.y, and RingArea.z. X corresponds to the horizontal position of the circle. If I drag all the way to the left, x goes to 0. If I drag all the way to the right, x goes to 1. Y corresponds to the up and down value of the circle. If I drag all the way up, y goes to 1, and if I drag all the way down, y goes to 0. As you'll see with other controls, Z simply represents whether I have my mouse down or not. When my mouse is down, in other words when I click, Z goes to 1, and then when I let go, Z goes back down to 0. So if I click, here you can see Z is 1, and then when I let go, Z is back down to 0. Now there may be cases where you wish that the ring area object did have a vector, and of course you can create it yourself. You can create a custom vector variable for this object, and you'd simply put the 3 x, y, and z coordinates inside of braces and separated by commas, as you saw in the previous video. The result is shown on the right, and as you can see, when I move the sphere, these numbers change, and they correspond to the x, y, and z variables shown on the left side of the screen. Now let's move on to the next type of object, the switch. Because we covered switches in so much detail in part 2 of this series, we're just going to quickly go over it here. If I click a switch, we can see that the switch has a single variable called x. X holds the on-off value of the switch. If I turn the switch off, switches.x goes to 0. If I turn it on, switches.x goes to 1. And that's our scalar variable because we only have one switch. Now if we've configured the switch to be 3 columns wide, then our x variable is now a vector. We don't have to create it ourselves. X just becomes a vector automatically whenever we have multiple switches configured. So here we have 0, 1, 1. That corresponds to off, on, and you'll see that vector get updated as I turn things on or off. Now down below, as we discussed last time, in order to access the individual values of switches, we simply use the bracket notation. We type switches.x, and then in brackets, type the index that we want to access. In this case, 0, 1, 2. So just as it's written up at the top, there's only an x variable, and it can be a scalar if there's only one switch, or a vector if there are multiple switches. Now let's move on to pads, which behave very similarly. As you can see, the pads object looks just like the switches object, and really the only difference with pads is that when you click them, they don't stay clicked. Whenever you let go, their value goes back down to 0. So here you see pads.x going from 0 to 1. Over here, the same vector and the same individual scalar values, one for each button. So if we turn them on and off, they don't stay on, but they momentarily stay on as long as we have our mouse held down, even if we drag across them. Just as we saw previously, x is the only variable that's available. So moving on, let's go to menus. Now menus are surprisingly simple to work with. You have a single variable. Instead of x, it's actually called selection. Here I've got 2 separate menus. Let me click on one and let's look at it in the project. Here you see the variable name is actually selection. In the properties panel you can see where we've added 3 items, items 0, 1, and 2 to our menu. You can continue to add more items at the bottom, up to 32 items per menu. I've created 2 separate menus just for the sake of demonstration. They both use the menu.selection variable. The variable holds a value, and that value corresponds to the value listed next to each item in the properties panel. Here we see item 0 has an index of 0, item 1 has an index of 1, item 2 has an index of 2, so they behave very similarly to switches. If I hold E and choose a different menu item, you can see that menu.selection is now 1. If I click the bottom one, menu.selection is now 2. On the right, I have a second menu, and the only difference is that I've named the items differently for a more real-world example. Here the first item is saw wave, and the menu selection is 0. Square wave, now it's 1. Sine wave, it's 2, etc. The values would continue to go up as you add more items to the menu. That's really all there is to menu variables. Let's go on to knobs now. Now, despite the fact that there's a lot written on the screen, the knob object is actually pretty simple. There are only 2 variables, x and z. Z we've seen before, how it turns from 0 to 1 when we hold the mouse down, and then it goes back down to 0 whenever we let the mouse up. But I've got 3 separate knobs on this interface, and that's because there's a setting called type, and that determines how x behaves. There are 3 different types of knobs: standard, bipolar, and endless. First, let's look at standard. Standard you saw before in the first and second videos. Knob.x goes from 0 on the left side all the way around to 1 on the right side. So that one's easy. The next one is the bipolar type. If we look at knob.x, right now you can see the value is 0.5, and that's because it's in the center. By default, it goes from 0 all the way around to 1, just like the standard type. But if you think about it, this type of knob might be useful for a zero-centered value where values to the left become negative and then values to the right are positive. So here we have an alternate version we could use. If we were to create a variable inside of this knob, for example, then we could write knob.x minus 0.5. If you keep an eye on this value, watch as I move around from left to right. When I go all the way to the left, I wind up with a value of negative 0.5. And then as I go all the way around to the right, I go up to 0.5. So that's how you could create a zero-centered value out of this type of knob configuration if you needed to. Finally, we have the endless type. Once again, let's start with just the basic knob.x to see how it behaves. Currently my value is up at the top, and the top is 0.5. 0 is actually at the bottom, so we'll talk about how to fix that in a moment. But first let's look and see how it works. As I go around, I go from 0 to 1, but as I keep going, the value continues to increase. The more times I go around, the larger the number becomes. It might be useful to be able to keep track of how many times around you've gone. For that, we can use a function that we haven't talked about yet called floor. Floor rounds any value that you pass to it down to the nearest whole number. For example, 1.5 would become 1. Negative 3.5 would become negative 4. If that sounds confusing, if we think of numbers being on a number line from left to right, we'll always be moving to the left with floor. Here we have floor, open parentheses, our variable knob.x, close parentheses. Currently the value is 3. Because knob.x is at 3.66, floor is rounding down always to the nearest whole value. If we continue to spin to the right, we'll see that all the way up to 3.99, floor is still giving us 3. So that's an accurate count of how many full rotations we've made up to this point. 4, 5, 6. Alright, I don't want to get too sidetracked with just one function. Let's move on. If we'd like to only know the part of the number that is after the decimal point, we can use the modulus operator, and that just means what's the remainder if we divide a number by another number. So if we divide 10 by 5, we get 0. In this case, since we want values between 0 and 1, we simply take the value of the knob itself, in this case 6.4, divide it by 1, which of course 1 goes into 6.4 evenly 6 times, and then we're left with 0.4 at the end. Once again, I don't want to spend too much time on this. If you'd like to know more about the modulus operator, there's plenty of tutorials out there on it. Finally, if we'd like for 0 to appear at the top instead of at the bottom, we can do what we did up here for our zero-centered value, and simply subtract 0.5 from the number. If you just saw this number change suddenly, I had to go back and correct an error in my formula. But now if I spin to the left, all the way back down into the 0 to 1 range, you'll see that 0 occurs at the very top instead of at the bottom. Here you can see the original value, knob.x, is 0.5, but now with our modified value, we've got 0 at the top. Alright, that's more than enough on the knob object. Let's move on to the fader. I promise to spend less time on this one. Just as with the switches object, we've seen the fader object before. Fader objects have two variables, x and z. X is of course the value, z is whether your mouse is down or not. Fader.x changes as we drag up and down. Fader.z turns to 1 when our mouse is down and 0 when it's up. Here's a demonstration of a left-right configuration. There's no special setting to turn a fader into left and right. You simply resize it so that it's wider than it is tall, and it automatically becomes a horizontal fader instead of a vertical one. Fader variables are both scalars, so they're very simple to work with. Let's go on to the range object. Just as with faders, the range object can be configured to be either horizontal or vertical. In this case, you'd swap it back and forth with a checkbox, and then resize it as appropriate. I'm going to press undo. Okay, so the range object is no longer a scalar, it's a vector. It only has one variable, x. We can see it in the project panel if we scroll down. As I mentioned at the beginning, there are several objects where the manual doesn't specifically mention the z variable, but it's technically available to use if you would like to do so. But I won't demonstrate it here. Let's concentrate on x and how to use this control. So with the range object, we're dealing with a low value and a high value. When it's horizontal, that's left and right. When it's vertical, that's bottom and top. And since we said the x variable is actually a vector, let's look at this one first. The first value listed is the low value, and the second value listed is the high value. As I change the low section of the range, you see the left number in the vector change. As I change the high value, the right number changes. Just as we've seen before, accessing scalars within a vector, we've used our bracket notation here on the left side. Taking a look at x0, it changes as I change the low value, and x1 changes as I change the high value. Range objects are pretty easy to work with, so let's move on. MultiSlider objects behave similarly to switches objects, in that they can act as both a scalar or a vector, depending on whether we have a single slider or multiple sliders. MultiSlider objects behave like faders. Let's take a look at the single case first. MultiSlider.x. As I drag from 0 to 1, it acts just like a single fader. So it's very simple. Once we configure the MultiSlider object using the slider parameter here to a number greater than 1, we get that number of sliders. What we wind up with is a vector with one value per slider. As I change the value of the first slider, the first element in our vector goes up and down. Second object, third object. Once again, we can access scalar versions of each of our multi-slider sub-objects using bracket notation. Slider 0, you can see here, multislider.x, open bracket, 0, close bracket. Once again, to demonstrate, keeping an eye on the other two scalar values below, you can see them change as I change them here. So MultiSlider objects function very similar to faders, and their variables can be accessed in a very similar way to switches, as you've seen. Let's move on to the Breakpoint object. The Breakpoint object might seem a little bit complicated at first, but it's really not that bad after everything we've already seen. Let's look at the simple case where the Breakpoint object has been configured with only a single point. The object itself has three separate variables: x, y, and z. Each of these variables can function as a scalar, as is the case on the left-hand side, or as a vector, as on the right-hand side. The x variable holds the x coordinates for the point. If I drag left and right, I can see breakpoint.x going from 0 to 1. The y variable holds the vertical location of the point, 0 to 1, and z, as always, holds whether the mouse is down or up. So the single point is pretty easy to understand. Now let's consider the case where our breakpoint object has multiple points. In this case, the x object becomes a vector of all of the x coordinates of all of the points. So this would be our first point's x coordinate, this would be our second point's x coordinate, and this would be our third point's x coordinate. Let's see how that works. We drag this left and right. There are the first point's x coordinates moving. Now the second one's moving, and now the third one's moving as we go from left to right. Similarly, the y variable holds a vector of all the y coordinates. If I drag the first point up and down, I see it going from 0 to 1, second point, 0 to 1, third point, 1, back down to 0. The z variable, of course, holds a vector of all of the mouse downs. In this case, it would be possible to detect which point was currently being acted on by looking to see which scalar within the z vector was a 1. When I'm dragging the first point around, the first element in the z vector is going to be a 1. When I'm dragging the second point, the second element is going to be a 1. When I'm dragging the third point, the third element is going to be a 1. We're not going to go into depth about that, but that could be useful at some point for you. Now, if we wanted to, we could actually build up our own vector, one for each point that we have in our breakpoint object. That would simply work by putting the x variable, y variable, and z variable of a single point inside of braces, thereby forming a vector. Keep an eye on this one now while I move point number 1. Notice how all the values change. So just to be clear, we're taking breakpoint x bracket 0, which is the first element in our breakpoint.x vector, breakpoint.y bracket 0, which is the first point in our y vector, and breakpoint z bracket 0, which is our first point in our z vector. Similarly, for point 1 and point 2, we're taking the second x, y, and z scalars and the third x, y, and z scalars and creating a vector out of those. These could easily be placed into a variable inside of our breakpoint object if we wanted to. I'll demonstrate that just with a single point. If I click Create Expression, I'll call this point 0 and press OK. I could copy the formula that I have written here on the right-hand side. It says breakpoint 2 in here because, truthfully, This object is named Breakpoint2 since we have two Breakpoint objects on this page. I've labeled them here simply Breakpoint just to keep it simple. But I'll copy this as it is and paste this into our new variable we've just created, .0. Now, here I can simply type Breakpoint2 .0. You need to be careful of capital letters because they do matter in Lemur. Alright, as you can see, the value remains unchanged and still tracks our first point. That's enough on the Breakpoint object. Let's move on now to the MultiBall. And the MultiBall you'll find is very similar to the Breakpoint object, so it really shouldn't take much explanation. Just as with the Breakpoint object, on the left side we've got a MultiBall that's configured with only a single ball. There are three separate variables, x, y, and z, and these function as scalars on the left-hand side and vectors on the right-hand side. If I move this, the variables change as expected. If I move these, the variables below change as expected, just like they did for the breakpoint. The breakpoint had points going left to right, and so it was easy to tell which point was number 0, 1, or 2. In this case, since the balls can be positioned in any way, I've enabled the numbers checkbox so we can see which ball is which. At this point, if you need to pause the video to take a look at the rest of what's on the screen, feel free to do so, but I really don't think there's any more I should have to explain at this point because the MultiBall works just the same as the Breakpoint object. So in this video we've covered in detail every object that you are likely to use in most of your interfaces and all of the variables that each of those objects contain. We haven't discussed parameters and we haven't discussed attributes. We'll have to save those for another day. Thanks for watching.